Good morning, friends, and welcome to another class. We'll be looking at the final section of separation method today. And in this session, we will look at the centrifugation and chromatography. And under chromatography, we focus mainly on what we call paper chromatography. We'll just note that. So let's start with centrifugation. Okay, so for to start, let's take something like maybe milk or even blood. For those of you who do not know, these substances are mixtures as well. They are mixtures. So blood is a mixture, milk is a mixture. And for example, when you take blood, it's made up of water. That's the main component of blood. And it's also made up of what you call blood cells. So we have blood cells mixed with water to form blood. There are other components in there, but I'm interested more in the solid component than the water component. Now, when you look at blood carefully, you'll be tempted to think that the blood cell component and the water component mixed uniformly to form an homogeneous mixture. However, the truth is that that mixture is not an homogeneous mixture. It's actually a suspension. Now, so what actually is happening here is that the blood cells are so tiny and lightweight that they suspend within the water molecules of blood. And because they are so tiny and lightweight, they will not settle. If they were larger and heavier, those blood cells component, the solid component, would settle at the bottom and the two could be separated easily. But you have the situation where the blood cells component are so light they will not settle. So in this case, it will be very difficult for you to use a method, for example, such as decantation to separate the two. And because the blood cells are also so tiny, even when you try using filtration to separate the blood cells from the water, it will not be possible as also because the blood cells are so small that they can pass through the filter paper when you try doing that. So that method will also not work out. Even using a method like evaporation and distillation would also not help. So there should be a way for us to separate the two, water and blood cells anyway. How do you do this? Maybe we can think about a way around it. What if we can force the blood cells to settle? Although naturally, when you put that mixture down, it will not settle. Even when you put it down for 100 years, it will not settle. There should be a way for us to force those blood cells to settle. That's where the instrument called a centrifuge comes in. So we can use the centrifuge to force the blood cells to settle. Then it will be easier for us to separate it from the water. So let's look at how this can be done. So we are using the centrifuge to do this. Okay, so let's put blood into a test tube. So this test tube is blood. And remember, this blood has water component and it has blood cell component in there. So all we do or all we will do is just to put the test tube of the mixture of blood into the centrifuge. Then we'll turn on the centrifuge. Once we do that, the centrifuge will move at a very high speed. As it moves at a very high speed, the solid suspended particles will be forced to settle at the bottom. So it will form something like this. We will still have this test tube at the end of the experiment. Water component will still remain in there. So you have the water component. However, the solid component of the blood will be forced to settle at the bottom like this, like a bolus. So we have the water component here, then we have the blood cell component here. It forms something like a bolus at the bottom. So you realize that the centrifuge has helped us to separate the two. At this point, it will be very easy for you to decant the water component from the blood cell component. And I believe you remember the word decant, to just pour out. So decantation simply means pouring out that water component, leaving behind the blood cell component. And as simple as that, that's what centrifugation is all about. Remember, you would use this technique mainly for mixtures that are suspensions. So like blood or milk, they are suspensions, and it will be difficult for you filtration or decantation to separate them because the particles are so tiny they will not settle. So you need to force them settle by using the centrifuge. Afterwards, you use the method of decantation to separate the water. Remember, it's for suspensions like blood or milk. You can think of other suspensions. So that is the explanation for centrifugation. Let's quickly look at chromatography. And under chromatography, like I said earlier, we focus on the paper chromatography. There are various types of chromatographies, but our focus will be on the paper chromatography. Now, a few things to note. In doing chromatography, you need a filter paper for this process. And so this diagram shows a filter paper. And please let me explain a few things before I even start. This way of looking at chromatography is going to be very simplistic. And moreover, and not going to give you details because the course is an integrated science course. So I'll leave the details out. The idea is to make you understand the concept behind this process of separation. So I'll not bring in some details. So that's what you need to understand. Understand the concept. Maybe go read the textbook or my summary sheets, and that would give you a better explanation. So let's continue. So you need a filter paper for this. And the filter paper used in paper chromatography is called the adsorbent. All right, that's the absorbent. Now you also need liquid for this, which we call solvent for this method. So let me take a beaker, and inside this beaker, I'm going to put a liquid. This liquid used in chromatography is called solvent. And this solvent, it could be water, it could be ethanol or alcohol, it could even be propanol and other no's. So it could be ethanol, water, propanol, methanol. All of them are examples of solvents you can use in this chromatography. And the other thing is this: chromatography would normally be used at your level to separate between the inks or the dyes within or the pigments within inks or dyes. I'm not sure I've confused you. So when you take an ink or a dye, let me just draw a spot of an ink here. This is a spot of a dye. Inside this dye, you have various colors that join together to form this spot, this dye. So you can separate those colors, various colors, using this method. And that's at your level for integrated science. But remember, chromatography actually goes beyond the scope of inks and dyes. It's used extensively in the world of molecular biology and genetics. So those who be reading chemistry or biochemistry would be using it a lot, but for integrated science, the focus would mainly be on dyes and inks. So let's continue from there. So let's see, how do you do this? So quickly, let's take the paper, the filter paper, in this case our absorbent. So all you do is just to put the ink or the dye on the paper. Usually at the bottom, you draw a line with a pencil. Then on that line, you put your spot of ink or dye there. Then you dip the tip. So this is the tip of the filter paper. You dip that tip into your solvent. You dip it. So that is the solvent. So that's the beaker containing the solvent. You dip it into it, just the tip, not the entire filter paper. Now, so that's what you do. Now, so here in this case is ethanol. We are using ethanol as our solvent. Now, when you do this, what do you think would happen? Now, the ethanol will rise through the filter paper. When you do this, it will rise from the bottom to the top. And whilst it rises from the bottom to the top, it will move along with the ink, the spot. And please, I need you to note something. The ethanol you used, the spot or the ink should be soluble in that ethanol or in that solvent. So solvent, so remember you use solvent in which the spot of ink or dye is soluble in. When the ink is not soluble in that solvent, that ink will not move along with the solvent. So here in this case, let's assume that our dye is soluble in the ethanol. Then the experiment will work. Other than that, the ink will not move along with the ethanol whilst it moves from the bottom to the top. So remember that. So the thing is that whilst the ink moves from the bottom to the top, remember we've established that this ink has various pigment, let's say red pigment, yellow pigment, green pigment. So whilst the ink move, because these pigments move at different speeds, they will be separated. And let me explain this in a better way. This pigment you see here contains red pigment. So let's assume that the red pigment moves faster than the yellow pigment. And the yellow pigment also moves faster than the green pigment. What it means at the end of our experiment, the red pigment will be at the top somewhere here, followed by the yellow pigment which will be somewhere here, then our green pigment which will be somewhere here. So you see, because these pigments move at various speeds in this particular solvent, what it means is that at the end of the experiment, they are going to be separated from each other at different positions on the filter paper, the adsorbent. So that's the main concept behind chromatography. And please note this, you use an adsorbent, usually the filter paper, you would use a solvent, which is ethanol, it could be water, it could even be propanol, and the spot or the ink that will be used should always be soluble in the solvent. If it is not soluble, your experiment will not work because the ink would remain at its position. It will not move for the component to be separated. So I guess that's all you need to know about chromatography. You read the summary sheet so you can understand this concept better. So that's what chromatography is all about. Guys, thank you for watching the video, and please share the video with your friends who are struggling in integrated science and core mathematics. Try and give me a thumbs up. If you have not already subscribed, subscribe to the channel. You need to encourage me to do more of these videos. So thank you very much. Take very good care of yourselves. I'll meet you in the next video. Bye.